Hi everyone. Today we're going to be talking about a very commonly used algebraic expression which is used a lot whenever we're talking about algebra. And that expression is, well, as you can see, a plus b whole squared. So today we're going to be talking about the different ways you can write this expression, and we're also going to be talking about how you can visualize it geometrically. So first of all, let's start off by talking about what is a plus b whole squared. So first, let's talk about that little 2 over there. So that 2 is our squared unit, which means that we're multiplying a plus b into a plus b. So that's going to be a plus b times a plus b. So a lot of the time we don't use that times symbol over there, so it's usually cut off, and we just write it simply a plus b and a plus b. So let's talk about the FOIL method. That is when you take the first digit or variable or number and you multiply it by all the digits variables in the next bracket. So what is a, I'll use a different color here, a times a. So a times a is a squared because we're multiplying one thing by itself. So we're going to write that down, a squared, and then what is a times b? A times b is ab, so a squared plus ab. Then what is b times a? Well, it's the same thing that we just said before, ab, so a squared plus ab plus ab. And then lastly, what is b times b? Well, b times b is again b squared because we're multiplying b by itself. So a squared plus a squared plus ab plus b squared. So if we have 2 of these ab's, then we can write that down as a squared plus 2ab plus b squared. So this is our first method that we can find out where a plus b whole squared gives us a squared plus 2ab plus b squared. Oh, that is off. Now let's talk about the second method where we can find out the value of a plus b squared. So whenever we're multiplying any 2 numbers by itself, it could be 8 times 4 or 6 times 7 or 16 times 27 or even 864 times 239. We could use a few different methods, but one of the most commonly used methods is this one, where let's take this example over here, 16 times 27. So this is one of the most commonly used methods, and we can do the same thing for variables too, because it really doesn't matter what you're multiplying it by. It just matters how you're multiplying it. So we've written it down. So what is b times b? Well, that's b squared. What's b times a? Well, a, b. So we're going to write down the signs in front of b squared. So b squared is positive, so we're going to write down our plus sign. Now moving on to a. A times b is again ab, and a times a is a squared. And again, ab is positive. Now we add them up. B squared plus 0 is b squared. AB plus AB is 2AB. And a squared plus 0 is a squared. So in both ways, we got the same answer, which is a squared plus 2ab plus b squared. And again, a squared plus 2ab plus b squared. So both of these are methods in which you can add them together, multiply them together. And now we're going to be talking about how you can visualize this geometrically. So over here, I have a square. Actually, I'm going to make this black. So, this may not be a perfect square, but let's just say it is. And over here, before we talk about squares, let's just talk about the variables in a plus b. Well, the variables in a plus b are, well, pretty obviously a and b. So what happens when we square this? Now, a common misconception of a plus b squared is that this is equals to a squared plus b squared. And this is a really common misconception. So try not to get confused, even though it can seem pretty deceiving, because a plus b squared, well, it looks like as if the exponent can be put on the a and then put on the b again to make a squared plus b squared. But that is not right, and that is the wrong answer, because, well, a squared plus b squared is not a plus b whole squared. So we talked about the methods on how to find what a plus b whole squared is, and you can use one of those methods to figure it out by yourself. But now let's talk about the visual representation. Over here, I have a line, and this line over here is, let's call it A. Actually, let's move this down a bit. Or, okay, I'll remake that. So over here, this is A. Let's name this A. I'll probably move this a bit. Okay, so over here, we have A. Now, if I squared this, A squared, and I made this into a square. Oh, I just realized my line isn't perfectly lined up. Well, anyways, let's say this is a squared. So over here, that means this is A, and this is A. So that means they're all equals to A. So the area inside of this is A squared. Now, if I added B to this, so I'll make a new square over here. Over here, this is our A squared. From here to here, and from here to here. This is all A. Now, if I added B over here, oh, yikes, that isn't perfectly lined up. So over here, now this new length that I have added right here is B. So over here, you can tell that the length from here to here is a plus b because, well, all the way over here, it's a, and then over here, it's b. So we can call that a plus b. Oh, yikes, that does not look good. So over here, our length is a plus b. Now, if we wanted to find the area of this, what would we do? Well, we'd probably times a plus b into a plus b. And you can do that using the methods that we talked about. But over here, we're talking about a visual representation. So if let's break this square into a few pieces. Over here, I'm going to break it right here and right here. So that means over here, I'll use a different color right here. And right here. So I've broken this square into 1, 2, 3, and 4 pieces. So if we wanted to find out the area of this square, we can find it out using a few different methods. But the method we're going to be using over here is how we can notice that over here, I'll use a different color. Over here, this square is obviously a squared. The area of this square is a squared. And the area of this square is b squared. Now, then what's the area of the two remaining rectangles? Now, if we notice, we can see that over here, this length is a and this length is b. So we can say that it's a times b, which is AB. So over here, we have two rectangles. Oh, yikes. We have two rectangles which have an area of AB. So if we wanted to find the area of the whole thing, we can just add up the area of these 4 pieces, which is a squared, b squared, ab, and again ab. So let's go ahead and do that. A squared plus ab again plus b squared gives us, well, ab plus ab is 2ab. So a squared plus 2ab plus b squared. And if you notice, this is the same as this and this. So that means all 3 methods work the same. Now, I wouldn't really say the last one we worked on would be a method. This would be more like a visual representation. But either way, whoa, that took a long time to write. But either way, all 3 of these give us the same answer to the question we originally asked, what is a plus b? So let's summarize that one time so everything stays in our brains. There are 3 methods, more like 2 methods and 1 visual representation to finding a plus b squared. That is using the FOIL method, where you simply multiply it inside of the brackets. So a plus b times a plus b would be a squared, then a times b plus ab, then b times a plus ab again, and then b times b, which would be b squared, which gives us a squared plus 2ab plus b squared. Then the second way to finding what a plus b squared would be multiplying it simply. So over here we would do a plus b times a plus b, which would give us b squared, then again ab, then again ab because a times b, and then a times a is a squared. One important thing to note whenever you're doing this is make sure that like terms are with like terms. So b squared cannot be added to ab or a squared. So it has its own column and it has no like terms. Over here, the only like term we have is ab and again ab. So that is something important to note whenever you are multiplying equations. So over here, b squared plus, well, nothing is b squared. Then ab plus ab is 2ab. And then again, a squared. Then our last one, which was a bit tricky, is visualizing it. Oh, why did I write down b over here? Third method, yeah. This isn't a method. This is more like a visual representation. I hate writing down this. It takes so long. And then for this, we would create a square, then separating it accordingly. Oh, I think that's a bit too low. So over here, this is a squared, this is b squared, this is a times b, and then this is ab. So, I'll write down the lengths. A and then b. So over here, all three of these, 1, 2, 3, and 4, all four of these. So a squared plus ab plus ab plus b squared is a squared plus 2ab plus b squared. So in all three of these, we got the same answer, a squared plus 2ab plus b squared. Again, a squared plus 2ab plus b squared. And then lastly, a squared plus 2ab plus b squared. So thanks for watching this video, and if it helped, make sure to drop a like and subscribe. Thanks for watching. Bye.